Welcome to class today, pre-cal students, on Thursday, the 29th, I believe. Yes, that is correct. And guys, wow, I didn't get any phone calls. Nobody dropped the class after yesterday's lesson, so that's good. That was a tough lesson yesterday, way to hang tough and get it done. And now you're going to reap the benefits of an easy lesson, okay? We're going to take a day today, Thursday, and let me go ahead and give you a heading. Sorry about that. Not sure what I was thinking. We're going to look today at solving linear equations. Now, these are the easy equations you had in 8th grade, 9th grade, and 10th grade. And if any of you four young men struggle a little bit with algebra or equations or those types of things, then don't hesitate to ask questions at all, please. No problem with that. You know I'm usually prepared, by the way, students. I'm sorry, my book is not beside me. I'm all wired up here with a headset and a microphone. I think it's R.7. It might be R.6, but I'm 99% sure it's R.7, and the date today's the 29th. Anyways, if some of you struggle with solving these equations, just work these out. Follow along. Don't be scared. Don't be worried. I'm going to teach you and bring you along and help you, okay? But we're looking at a grand total of, I forget how many problems. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 problems, and there's no homework. Okay, did you hear that? No homework. This video is your homework. All that we're going to do today is work these 14 problems. It won't take long, and you're done for the day. And there's no class on Monday either, so notes video today. One video today, no homework to do, no homework help video. And then Friday will be a little tougher. We're going to solve some quadratic equations. You will have homework, but no class on Monday. You will have a quiz over the weekend. Don't forget that. And so with that in mind, let's jump into this and let's review how to solve linear equations, okay? Now remember, your goal is always to get x all by itself, all right? Now I'm going to say these steps over and over. You're going to get so tired of hearing these steps, but I'm sorry, that's just how it is, okay? All right, here we go. Let's solve some equations. When you're solving linear equations, you first of all want to simplify both sides. Well, there's nothing you can do to this side over here. It's just a 45. And notice on the left side, we have an x term and a constant term, so you cannot put those together. They're unlike terms. So there's nothing I can do to this side. The next thing you want to do is get x all by itself. So the first thing I want to do, by the way, this number that's always right next to the x, this number is called a coefficient. Always get rid of it last. Let me say that again. Always get rid of that number last. Save it for last, okay? So if I want to get x all by itself, there's two numbers I got to get rid of, a 6 and a negative 15. And I just said we're going to save 6 for last. So how do you get rid of a negative 15? Well, you pick it up and you move it to the other side. And when you move it to the other side, you change the sign. Isn't that easy? So you move the negative 15 over, it becomes a positive 15. So now I have 45 plus 15, that's 60. Since I moved it over, it's gone, and I'm left with 6x. Booyah, pretty easy. Now divide both sides by 6, and by the way, that's what you do whenever you have a number next to a variable like 6x. You divide by that number, and the reason you do that is it gets rid of it. And now you're left with x. And what's 60 divided by 6? 10. All right, let's continue on. Now, two of you young men, I don't know very well from your algebra background, so I hope you're getting this. You got my phone number, you got my email, you're not going to bother me. Your parents are paying me to teach you, so please contact me if you need to. Don't be embarrassed about that. Nothing embarrassing about that at all, okay? All right, there's nothing I can do to this side over here, and there's nothing I can do to this side over here, simplifying wise, because I've got an x term and a constant term, and they're unlike terms. So, nothing I can do. So next, I want to get x by itself. I want a 5 to get rid of and a negative 10 to get rid of. I'll save the 5 for last. So I'm going to bring this negative 10 over. When I do, it becomes a positive 10. And now I'm left with 5x equals 55, because 45 plus 10 is 55. And now I want to get rid of the 5, so I divide one side by 5. But if you divide one side by 5, you got to divide the other side by 5. Those 5s cancel, and you're left with 11. 11 is your answer. Moving on. All right, same thing. We have unlike terms right here, so we cannot simplify this side. It's simplified as far as it can go. I cannot simplify negative 5. It's all by itself. So the next thing I want to do is get t all by itself. I'm going to bring this 4 over, and when I bring this positive 4 over, it's going to be a negative 4. So use a calculator if you're weak with your sign numbers. Don't be embarrassed to do that. A negative 5 and a negative 4, when you combine them or add them, however you want to say it, you will get a negative 9. You're left with 9t. Now I want to get rid of this 9. Well, the only way to get rid of that 9 is divide by 9. If I divide one side by 9, I must divide the other side by 9. These 9's cancel, and I'm left with negative 1. Again, use a calculator if you need to. A positive 9 divided by a negative, a negative 9 divided by a positive 9 is a negative 1. Moving on to the next problem. Good. Now a little more complexity. Okay, let's look at this side over here. We cannot simplify this side because we have an x term and a constant term. They're unlike terms. We cannot simplify this side over here because we have unlike terms. So next we want to get x by itself. Now look, the only way you can get x by itself is if you get all the x terms on one side, okay? Now students, I don't care if you bring the 8x over and make it a negative 8x. That's totally fine with me. Or you can bring the 3x over and make it a negative 3x. I really don't care, okay? Either way, you will get the right answer or you're making a mistake, okay? I'm going to bring my 3x over, and when I do, I'm going to make it a negative 3x. Now that makes sense to me because I want to get my x's on one side. Now see this 48? If I'm getting my x's on this side over here, then I'm going to bring this 48 over here. And when I bring this 48 over, it was a positive 48. Now it's a negative 48. So I'm going to bring down my equal sign. Now let's see what we got. Use a calculator if you need to. A positive 8x and a negative 3x is 5x. X stays the same. A negative 12 and a negative 48 is a negative 60. Now you want to get rid of the 5. So we divide both sides by 5. These 5's cancel. Negative 60 divided by 5 is negative 12. Very, very cool. Moving on to number 9. Okay, same type of problem. Notice, let me reach very quickly for a drink of water. Excuse me. Okay, I'm back. I don't get to talk that often because I'm married. Just kidding. I shouldn't have said that. All right. Now, let's see what we got here. Okay, on this side, I have unlike terms, so you cannot simplify. Over here, I have unlike terms, so you cannot simplify. So, done with that. Now, I've got to move my y's. I've got to get all my y's on one side and my constant terms on the other side. So, again, you could bring the 7y over. If you do it right, you'll get the right answer. I'm going to bring my negative 5y over, like this. And when I do, it becomes a positive 5y. I'm going to bring this negative 1 over, like this. And when I do, it becomes a positive 1, okay? So, over here I'm left with 12y, 7y plus 5y. Over here I'm left with 24 because 23 plus 1 is 24. All right, very good. Now, I want to get rid of my 12, so I divide one side by 12, divide the other side by 12. The 12's cancel, and 24 divided by 12 is 2. Very good. Okay, same type of problem again. You know what, Miss J.R., this was redundant. Yeah, it is. And so is working on certain kicks in karate 100 times or doing certain traps in soccer, etc., etc. Practice. Practice is what helps you get better. Okay, on this side over here we have unlike terms, so you cannot combine them. Over here we have unlike terms, so you cannot combine them. So there's nothing we can do to each side simplifying. Now, we want to get our x's on one side and constant terms on the other. I'm going to bring my 12x over. Notice it's positive, so when I bring it over, it becomes a negative 12x. I brought it over, now it's gone. Now I'm going to bring this negative 4 over. When I bring this negative 4 over, it's going to become a positive 4. So notice now my negative 4 is gone. So it looks like I'm left with, on this side over here, positive 5 and positive 4 is positive 9. And over here, use a calculator if you need to. You've got a positive 3 and a negative 12. Combine those, you get a negative 9x. And now you don't want this negative 9 with the x because you want x all by itself. So we divide by negative 9. Divide the other side by negative 9. These cancel. And a positive 9 divided by a negative 9 is a negative 1. Let's continue on to number 13. These are unlike terms, so you cannot simplify or combine them. These are unlike terms, so you cannot combine them. So we cannot simplify either side. So moving on to step 2, I like to get all my a's on one side, or my variables, all my constant terms on the other. This is a positive a. I'm going to bring it over and make it a negative a. Okay, so negative a. I'm going to cross this off. It's gone. Now I'm going to take this positive 5 and bring it over. And what I do is going to become a negative 5. So I'm going to put a negative 5 right here. And now this 5 is gone. Now notice this negative sign right here goes with a 4. Okay, let's look at that for a second. That negative sign has nothing to do with the 5. The 5 is what? The 5's positive. That's why when I brought it over, it became negative. This negative sign goes with the 4, okay? All right. So my 5's gone. I brought it over here. Let's see what we got. Use a calculator if you need to. A negative 13 and a negative 5 is a negative 18. And a negative 4, and don't forget what's in front of the a, it's a negative 1. So a negative 4 and a negative 1 is a negative 5a. And now we're going to divide both sides by negative 5. You can use a calculator if you'd like to, that's fine. I'm going to reduce. A negative divided by a negative is a positive, and 18 over 5 is just simply 18 over 5. Or do you know what another answer you could put is? Or 5 goes into 18 3 times with 3 left over, so you could say 3 3/5. Or 18 divided by 5, use a calculator if you need to, you'll get 3.6. All of those answers are the same thing. It doesn't matter which one you use. All right, number 15, same thing. Unlike terms, so we cannot simplify. Unlike terms, so we cannot simplify. So we cannot simplify either side. I'm going to take this positive m right here, and I'm going to bring it over here and make it a negative m, like this. And now that I've done that, this thing is gone. Now I'm going to take this negative 7 and bring it over here, and when I do, it's going to become a positive 7, and now I'm done with this. So let's see what we're left over with. A negative 7 and a positive, or a negative 13 and a positive 7 is a negative 6. Don't forget what's in front of the m, even though you can't see it. A positive 3 and a negative 1 would be 2m. And now we want to get rid of the 2 so that m is all by itself. We're going to divide both sides by 2. Those 2's cancel. Negative 6 divided by 2 is negative 3. All right, moving on to number 17. Same thing. Unlike terms, you cannot combine them. Unlike terms, you cannot combine them, so neither side can be simplified. So next, I want to get all my variables on one side and all my constant terms on the other. I'm going to bring this positive 5x over. When I bring it over, it becomes a negative 5x. I change the sign, and now this is gone. And now when I bring this 11 over, obviously it's, and by the way, it's not a negative 11. Some students see this negative sign and think the 11 is negative. No. What's in front of that 11? It's not a negative sign. You can't see it, but it's a positive sign. So you're bringing a positive 11 over, and when you bring a positive 11 over, it becomes a negative 11, and now this 11 is gone. So what are we left with? Well, negative 3 and negative 5 would be negative 8x. Use a calculator if you need to. A positive 3 and a negative 11 would be a negative 8. And now we want to get x by itself, and what's with the x that we don't want? A negative 8. So we're going to divide both sides by a negative 8 to get rid of this negative 8 right here. And they cancel out. And you're left with, well, what's negative 8 divided by negative 8? Positive 1. Positive 1. Number 19. Oh, good. Finally something different. I'm starting to fall asleep over here. Now look at the right side. There's no simplifying you can do. You have unlike terms. So just bring those down. But look at the left side. You can simplify. You can take this to, well, Mr. Earhart, it's unlike terms. Hey, I've never said you can't multiply unlike terms. I've said you can't combine unlike terms. So we're going to take this 2 and multiply it by the x, and then also multiply it times the positive 7. So 2 times x is 2x. 2 times 7 is 14. Do you see how we simplified? 2 times x, 2 times 7. Now, I have a question for you. Can you take this side further when it comes to simplifying? Or do we have unlike terms? Well, you should know by now we have unlike terms. We have an x term and a constant term. Now, if there was an x here, then we would have like terms. But we don't have an x. So, now we should know what to do. Let's get all of our x's on one side and our constant terms on the other. So I'm going to bring this 5x over. And when I bring it over, it's positive here. When I bring it over, it's going to become a negative 5x. So we're going to cross this off. And now we're going to take this 14 and bring it over. When I do, it's going to become a negative 14. There we go. So we're going to cross this one off. And now let's see what we're left with. Well, positive 14 and negative 14, we're not dividing, we're combining. When you combine those using a calculator, negative 14 plus, or a positive 14 plus negative 14, you will get a 0. And then 2 and negative 5 gives you a negative 3x. Now, what is with the x that we don't want? A negative 3. So we're going to divide both sides by a negative 3. When I do that, these cancel, and 0 divided by negative 3 is 0. 0 divided by any number is going to be 0, unless you're dividing by 0. 0 divided by 0 is something else. It's infinity. We're not going to get into that right now. But 0 divided by negative 3 is 0. All right, number 21. We want to simplify each side. Well, you cannot simplify 24. 24 is just 24. But you can simplify this side. 5 times 2t and 5 times 5. 5 times 2t is 10t, and 5 times 5 is 25. Now, can you simplify this side further, or are they unlike terms? Well, they're unlike terms. So, we're going to go ahead and get t all by itself. Now, you could bring the t over if you wanted to. You could bring the negative 10 over if you wanted to. But if you did that, you would then have to bring the 24 over here. And that's a lot of work. I'm just going to do this. I'm just going to say, look, I'm just going to bring this 25 over like that. And when I bring it over, it becomes a negative 25. I'm going to cross this off. And now what are we left with? A positive 24 and a negative 25 is negative 1. Bring down your 10t. Now what's still with the t that you don't want? A 10. So we divide one side by 10 to get rid of this 10. Divide the other side by 10. And you're left with, these cancel out, you're left with t equals, now look, a negative divided by a positive is a negative, so negative 1/10 is one answer. Or you could also type negative 1 divided by 10 and you would get negative 0.1. Either one of those two answers are fine. They're the same thing. All right, now we're getting to have some fun. All right, woo, here we go. Look at the right side, 25. You can't simplify a 25. It's all by itself. But we can do some simplifying over here, students. See this negative sign in front of the parentheses? Remember, like the first week of class, we learned when there's a negative out in front of a parentheses, you can multiply it through, and it changes all the signs on the inside. So I'm going to bring down my 5y, take this negative sign, multiply it through. Negative times a positive would be a negative 2y, and a negative times a negative would be a positive 10. Well, looky here. We can simplify this side further, can't we? You always want to simplify each side as far as you can go. So 5y minus 2y. Look, they're like terms. 5y minus 2y is 3y. Positive 10 equals 25. Now, can you simplify this side any more? No, we have unlike terms. There's nothing else we can do. So we want to get rid of the 3 and we want to get rid of the 10. We always save this number for last. So let's bring this positive 10 over. When I bring this positive 10 over, it's going to become a negative 10. So this 10 is now gone. And it looks like we're left with 3y equals 15. 25 minus 10 is 15. And now to get rid of this 3 right here, we're going to divide both sides by 3. And y equals 5. Y equals 5. Let's take a look at number 25. What we got left? 25, 27. That's it. Wow, we're finally done. All right, number 25. Now, I can simplify both sides, so please pay attention, students. Over here on this left side, I can take this 7 and multiply it through the parentheses. So 21x plus 42. Now, can you simplify this side any further? No. You've got unlike terms. There's nothing you can do. Well, now let's come over here. Please don't take this 11 and multiply it through the parentheses. Look. If it was negative 11 and the 11 was right next to the parentheses like this, then you would multiply the 11 through. But students, the 11 is not right next to the parentheses. The negative sign is right next to the parentheses. So I'm going to bring my 11 down and then take this negative sign and multiply it through. A negative times a positive x would be a negative x. A negative times a positive 2 would be a negative 2. Now hold it. Look at this side. Look. You're not done simplifying. I see a constant term here, 11, and a constant term here, 2. Neither one of those terms have an x or a variable with it. So I'm going to bring this side down. There's nothing I can do with this side, 21x plus 42. But over here, I've got 11 and a negative 2. Positive 11. The 11 is not negative. The x is negative. I've got a positive 11 and a negative 2. Well, that's going to be 9 and then minus x. Now, can you simplify this side any further? No, you cannot. They're unlike terms. So, now we're ready to move stuff around. Okay, take this negative x and bring it over. When you bring that negative x over, it is going to become a positive x. So this is now gone. And now this 42, bring this 42 over. It's a positive 42, so when you bring it over, it's going to become a negative 42. So now this 42 is gone. Now don't forget what's in front of the x here. It's a 1. So 21x plus 1x would be 22x. And then we have 9. That's not a negative 9. That's an equal sign right there. That's an equal sign. A positive 9 and a negative 42 would be a negative 33. A negative 33. All right? Now, what's with the x that we still don't want? Well, a 22. So we're going to divide by 22, divide by 22, cross those off, and we're left with, are you ready for all of these answers? A negative divided by a positive is a negative. Now, I would not accept 33 over 22 because you can reduce that. So don't leave that for your answer, okay? There's going to be quite a few answers here. Let's drag it up here and get some room. All right, here we go. That would not work, so trust me. One answer could be a negative 3 over 2. Where'd that come from, Mr. Earhart? Well, 11 goes into both these numbers. 11 goes into 33 3 times, and 11 goes into 22 2 times. So there's one answer you could have, negative 3 halves. Or you could have negative 1 and 1 half. 2 goes into 3 once with the remainder of 1 over 2. Or you could have negative 1.5. All three of those answers are sufficient. And lastly, but not least, we are done. We're at the last problem. Let's go ahead and solve this linear equation. Take the 5 and multiply it through. We're going to simplify this right side. 5 times y is 5y, and 5 times 2 is 10. Now, can we simplify this side anymore, or do we have unlike terms? Well, we have unlike terms. We cannot simplify this side anymore. Now let's come over here. Take your 4, and by the way, when you multiply this 4 through the parentheses, don't multiply the 4 times the negative 6. No, don't do that. The 6 is not inside the parentheses. So it's 4 times 3, 12y, 4 times negative 1, negative 4, and then bring down your negative 6. Hey, I see some more like terms. Look, here's a constant term and here's a constant term, a negative 4 and a negative 6. So now I have 12y minus 10, because the negative 4 and a negative 6 is negative 10. And of course, you still cannot do anything to the right side, so we're going to bring that down. Now, notice we can take this left side no further because there's unlike terms. Okay? So here we go. Let's bring this 5y over, and when we do, it's going to become a negative 5y. Let's bring this negative 10 over, and when we do, it's going to become a positive 10. So we moved this over, it's gone. We moved this over, it's gone. And it looks like we're left with 10 plus 10 is 20, and 12 minus 5 is 7y. So now we're going to divide both sides by 7, and your answer would be this. You could have 20 over 7. That's totally acceptable. You can't reduce that. Nothing goes into it evenly. Or you could have 7 goes into 20 2 times, the remainder of 6 sevenths, 2 and 6 sevenths. Or, and I'm going to try to do this decimal in my head. I'll probably mess it up. Something like 8 would be 56, 40, 5, 35, 50, 7. It would be something like 2.857. It would go on, and it would either terminate or it would repeat. I'm not sure which, but there you go. Now, we will have a quiz on Friday. By the way, I've decided I'm going to start giving 5 bonus points to the students on their quizzes. Boy, that's a big help. If you turn in a homework integrity sheet with all 100, so if you do every single problem on every single homework assignment, and you turn in a perfect homework integrity sheet, I will give you 5 bonus points on your next quiz. So the quiz you're taking this Friday, sorry, but there won't be any bonus points on it. However, if you're doing your homework this week and next week, then the next quiz you take, you will be able to get 5 bonus points. So if you got behind on your homework already on Tuesday or Wednesday's video, get caught up, okay? Because when we meet on that Monday in a couple weeks, if you turn in a perfect integrity sheet, I will give you bonus points on your next upcoming quiz. Okay, that should take care of everything. Have a great day. I hope this was a lot better than the other video we did. You have no homework. If you got to go back and watch this again because you're still a little confused, and you know what? You got to do what you got to do, okay? And I hate that for you, but make sure you understand this math. Have a great day, and we will talk to you guys on Friday.